Hello, Austin High Maroons. This is the video tutorial about how to do the advanced level version of the ASI 9 project. This is Dr. Jewell. I teach math here at Austin High. So this is supposed to be me kind of demonstrating how to do this and just modeling what to do. All right, so for step one, we are going to collect some data. So in geography, you should have already done some research about 6 themes of your country. Now you're going to find data about 2 of those themes. You're going to do the following directions twice, once for each theme that you are picking. So I'd like you to go to a search engine like Google, Bing, or whatever works today, and then you type in your country's name, the indicator, the words data, and the words years, and then either the search engine will show you the data, it'll show you some graph, or show you a table of the data, or it's going to give you a web page that should show you the data you want. You want data based on years, not months or centuries or anything, and try to get data from some range between 2000 and 2024. The more dates, the better. The more recent, the better when it comes to what we're doing. We are predicting future values. So more recent and more years gives you better predictions. And so to make inputting the data and finding the graph easier, I want you to change your years into what they are minus 2000, meaning 2001 means 1, 2025 means 25. That'll make doing the data easier. It'll make finding the graph easier also. Okay, so then copy your data into this spreadsheet. You click that, it's going to have you make a copy, and it's going to look kind of like this. So here I have my example based on Google, let's see. So I Googled Bolivia population, oh, I can't spell the word population, data, years, like that. And it gives me a table of all this, that, or I can go down here and it gives me more. Gives me a lot of stuff. And you can go to like some of these websites like Worldometer is a pretty good one. And it would actually show you a graph. And based on the graph, you can see we have all our, so the X values are the year, like 2001 would be 0, and our Y value is the population. And so using that data, I already got the X values of the years. So like 8 means 2008, 19 means 2019. And my Y values are in millions. So like this is 10.2 million, 11.6 million. I have that. Okay, so what's next in the project? All right, now that you've done research on the current state of a country, you will use the data to predict the state of that country in the year 2075. We were going to do this using regression analysis. Regression is a statistical method that attempts to determine the strength and character of the relationship between the dependent and independent variables. We can use this to make predictions about the future. You will decide which regression to make predictions about 2075. So, being in advanced biology, that means you're either very good at Algebra 1, you're in geometry, you're above it, Algebra 2 or something. So that means you've been taught regression analysis before. That is something that is taught in Algebra 1, and you have been taught most of the types of regressions we're about to do. Okay, so how to use Desmos to do this. All right, so once I have my data here, I click drag. I'm going to copy, and I go to Desmos, and let me erase all this, pardon, and I do paste. So they don't really let you just paste like that, so I do Control V, and hey, look at that. It makes a table. Like you could press the plus sign, click table, and actually input all the data, or here it is. And notice it gives you this graph here. Well, that's not a graph, it's just the points that match this. Okay, so a new beautiful update of Desmos is this symbol right here. We get to click Add Regression. Okay, so now what I want you to do is I want you to test out 4 different types of regression. you are either going to test out linear, quadratic, exponential, and logarithmic. Okay, so linear, quadratic, and exponential, that is taught to you in Algebra 1. The linear and exponential do come up again in geometry. Logarithmic might be new to you, unless you might have been taught that briefly in Algebra 2 if you're an Algebra 2 student, but this is a good thing to learn today because, frankly, most situations such as population or really any real life situation is probably a logarithmic situation. Like this, like logarithmic, in my opinion, is the most realistic type of regression. It applies most accurately to most situations, actually. So I think it's a good one to try. And you're going to try all four of these, and we're going to find the regression that has the r squared value closest to 1. What's that mean? Well, now notice here, I made it, and I have it on linear regression, because that's why I made a straight line like this. It creates the equation. And then in statistics, ignore the r squared. I want values close to 1. 0.9972 is really close to 1. That's a very, very good r squared value. Now, the closer the r squared value is to 1, the more accurate this type of regression matches the data. Okay. If the r squared value is close to 0, that would mean the the type of regression we're doing is an awful model for the data, but close to 1 means it's a great model for the data. So that's what linear is. We kind of have to remind ourselves, all right, 0.997, really good. Let's try out quadratic. 0.9975. That's pretty, is that closer? That is actually a little bit closer. That's fantastic. That's actually a little bit closer. So quadratic is actually better than linear. Interesting. All right, now let's test out exponential. 0.9927. That is not closer. And notice like it changes the line every time I do this. And the final one I test out is logarithmic. Whoa, it doesn't work. See? It can't be that then. Yeah, the reason why it doesn't work is because it can't actually have x values that are 0. They can't have y values that are 0, I mean. So that's weird, it doesn't work. Oh well. So which one's best? It looks like quadratic is. All right. So that's that. Let's see what happens with quadratic. Now let's go back to the directions. Okay, so I think it's quadratic. So in the next row, I'm going to type in the equation you're given, but instead of typing y equals, I type in f of x equals. So I don't have to type in the equation, just copy and paste. And so instead of type the y equals, you write f of x equals. Now here's the deal. So in the next row, I'm going to type in f of 75, and that should give me a prediction about 2075. But here's the deal. If your prediction shows a negative number, that means we chose the wrong type of regression. You need to go back to step 3 and try the second best. Like the next best, like the second best regression type. And because negative values are not realistic, there's no such thing as negative population. You can't have negative 100 people. Okay, if you're doing, what's another indicator, like something about like arable land? You can't have negative acres of land. That makes no sense. You need positive values. You need positive values. So let's see what happens. I don't know what's going to happen here. So in this row, I type f of x equals. And then I'm going to click this. I'm going to copy it. It's Control C, Control V makes it happen. There it is. Okay, and then the next row, f of 75. Okay, so I do think quadratic is a pretty good thing that works. So because what that means is that in the year 2075, the prediction is there would be 18.8 million people in the country of Bolivia. Okay, so now I have my information, and what you would do in the next part is you're going to record it. So there's a graphic organizer here. You would click on this, make a copy. And all right, here is a example of me. I did like Indonesia and population. So I used a snipping tool or a screenshot. I screenshotted the table and graph. I should have done a better job with that. You should see the table. And then here's linear. I chose linear. Like linear subfill is the best. Here's the equation of best fit, and this is the prediction. And so that's my model, which needs to be fixed a little bit. And here is where I want you to kind of fill in your own information, like country indicator, table and graph is like screenshot that. Bolden or underline, whichever one of these you used. Type the equation, which is, you don't type it, just copy and paste. Then copy and paste the prediction, and you do that twice because there's 2 indicators you do this for. And after that, I want you to submit the spreadsheet you did, the graphic organizer you did via this link where it says this submission page, which is a Google form where you can upload both of them and press submit, and you are done. And that is the entire math section of the ASI 9 project. If you need my help, or you could probably just ask whoever teaches you math for help, but I'm in room 259. I teach math here, so that's it. I hope this was helpful. Have a good rest of your day.